Hello everyone and welcome back to this episode of AI Governance Engineering with myself, Gavin. And today I want to talk about something that's been bugging me silently for a little while. So if you've been on LinkedIn, you've probably seen the term explainability thrown around constantly with things such as we need to make sure AI is explainable, our AI is explainable. We prioritize explainability. It's kind of become this buzzword that everyone uses, but nobody seems to actually understand what it means technically. Well, I've recently discovered something that's completely changed my perspective, an actual ISO technical standard that defines exactly what explainability means, how to implement it, and who needs what kind of explanations. It's called ISOIEC Technical Standard 6254, and it came out in 2025. It's a 69-page technical specification that most people in the industry don't even know exists. So today I'm going to break down this entire standard for you, and by the end of this video you'll understand explainability at a level that most people posting about on LinkedIn simply don't. So let's start with the problem. Explainability has become one of those terms that sounds great in a sales pitch but means almost nothing in practice. LinkedIn treats it as a checkbox. AI should be explainable. Our AI is explainable. But there's no guidance on how to actually achieve explainability for specific contexts. People use terms interchangeably without any technical understanding. The result? Confusion across the entire industry, wildly inconsistent implementations, and false assurances to users and regulators who deserve better. But here's the thing, ISO 6254 fixes this. It's a 69-page technical specification with rigorous definitions and implementation guidance. So let me show you what it actually says. So what exactly is ISO 6254? Well, the official title is Objectives and Approaches for Explainability and Interpretability of Machine Learning Models and Artificial Intelligence Systems. It was published only in September 2025 by the ISOIEC, the official International Committee for AI Standards. This is a technical specification, which means it provides normative guidance for implementation. What's crucial is that it covers both ML models and AI systems, because you can have an interpretable model, but if it's embedded in a system that doesn't surface those explanations to users, what's the point? As far as I know, this is the only international standard specifically and comprehensively addressing AI explainability, and yet almost nobody talks about it or refers to it. Okay, so let's dive into the first major section, definitions. Now this might sound boring, but trust me, this is where the standard really shines, because the whole problem with the explainability discourse is that nobody agrees on what these terms mean. ISO 6254 fixes that with precise technical definitions. First up, interpretability, and here's the official ISO definition: property of an AI system or ML model where aspects of its structure or behavior, including the logic of its outputs, can be understood by humans. So notice that key word, can. Interpretability is about the potential for understanding. It's an inherent property of the system itself. A decision tree is interpretable because you can trace through the logic. Now here's explainability, and pay attention to the difference. Property of an AI system or ML model where its structure or behavior, including the logic of its outputs, is presented to a targeted audience in a clear manner. See the difference? Is presented. This isn't about potential, it's about active communication. Explainability requires that someone actually receives and understands information about the system. And notice targeted audience. Now this is crucial. An explanation that works for a machine learning engineer is probably useless for a loan applicant who was denied credit. So let me really drive home this distinction because it's fundamental. Interpretability is about the system itself. Can it be understood? It's an inherent property. A decision tree, you can just look at it and follow the logic. Explainability is about communication. The system actively presents information to an audience in a clear manner. This requires some kind of explanation mechanism, whether that's a SHAP visualization, a natural language summary, or an interactive dashboard. And here's the key insight. A system can be interpretable without being explainable. If nobody ever surfaces those explanations to users, and the system can be explainable without being inherently interpretable, if you add post-hoc explanation methods to a black box model. Now we get to one of the most valuable parts of ISO 6254, the stakeholder framework. The standard identifies distinct stakeholder categories, each with different explainability needs. And this is huge because it forces you to move beyond the generic that AI should be explainable to explainable to whom, for what purpose. So let me show you the 6 key stakeholder categories ISO 6254 identifies. First, the AI user, the person using the AI's outputs. They need to understand what outputs mean and calibrate their trust appropriately. The AI developer, the technical team. They need explanations for debugging, verification, and improvement. The AI subject, and this is critical, the person affected by the AI's decisions, often with no choice in the matter. A job applicant screened by AI, someone denied a loan, for example. The regulator, verifying compliance with regulations like the EU AI Act. The AI auditor, assessing safety and fairness. And the AI provider, the company offering the product, needing to demonstrate compliance and build trust. So the key insight here is that there is no one-size-fits-all approach. Different stakeholders require fundamentally different types of explanations. So let me go deeper on the AI subject, because this is often the most overlooked stakeholder. The AI subject is the individual affected by an AI system's decision. Now, what makes this category unique is that they often have no choice in the interaction. They didn't choose to be screened by an AI during a job application. Their needs are quite profound. They need to understand decisions affecting them, contest decisions they believe are incorrect or unfair, and know what data was used and how. Critically, the explanation requirements here are very different. They need non-technical, accessible language, not feature-important scores. They need actionable information. For example, what can they do differently? And they need recourse information. For example, how can they appeal? This is often the most overlooked stakeholder in AI development, and it's arguably the most important from an ethical and regulatory perspective. Now we come to another major contribution of ISO 6254, lifecycle integration. The standard makes clear that explainability isn't a feature you add at the end. It's a practice that must be integrated throughout the entire AI system lifecycle. ISO 6254 identifies 6 main lifecycle phases, and it specifies how explainability should be addressed in each one. First is inception, where you define requirements and goals. Second is design and development, where you actually build the system. Third is verification and validation, testing and evaluation. Fourth is deployment, putting the system into production. Fifth is operation and monitoring, running the system and tracking performance. And sixth is re-evaluation and retirement, assessing ongoing needs. And here's the crucial insight. In each phase, there are 2 considerations. First, developing and evaluating the explainability component itself. And second, using explainability to aid that particular phase of development. So in the design phase, you're both building your explanation mechanisms and using explanations to verify your model is learning correctly. This dual role of explainability runs throughout the entire AI system lifecycle. So let me highlight some critical lifecycle insights. First, inception failure. Most organizations bolt on explainability later. Requirements must be established before any code is written. Second, dual track development. Track A is building the explainability component itself. Track B is using explainability to aid development, for example, debugging, verification, and identifying biases early. Third, ongoing responsibility. Explainability isn't done when you deploy. You need to monitor explanation accuracy over time, collect feedback, and update as the model evolves. So now let's get into the real technical meat. ISO 6254's property taxonomy. Now this is a framework for characterizing any explainability method across multiple dimensions. The taxonomy has 4 main categories. First, explanation needs. Properties describing what kind of explanation is required. This includes the expertise profile of the audience, the scope, local versus global, completeness, and depth. Second, forms of explanation. How explanations are actually presented. Is it numeric, visual, textual, structured, example-based, or interactive? Third, technical approaches. The methods used to generate explanations. and we'll get into those in detail. Fourth, technical constraints. Practical limitations like whether the method is model agnostic or specific. So let me expand on forms of explanation, because this is where you make critical choices. Numeric forms include probability scores, feature importance values, and these are best for experts who can interpret raw numbers. Visual forms include saliency maps, attention heat maps, and graphs, and these are best for image data or when you need to show spatial patterns. Textual forms use natural language, and these are best for non-technical audiences and AI subjects. Structured forms present explanations as decision rules or trees, and these are best for auditors who need to verify compliance. Example-based forms show similar cases or counterfactuals, so if your income had been 10k higher, the outcome would have been different, and these are excellent for contestability. Interactive forms let users explore model behavior themselves, and this is best for developers. So the key insight here is the same model may need multiple forms for different stakeholders. Okay, now let's get into the 4 technical approaches to explainability that ISO 6254 identifies. ISO 6254 categorizes all explainability methods into 4 fundamental approaches. First, empirical analysis. And this is about analyzing model behavior through systematic testing and experimentation, such as error analysis, ablation studies, specialized datasets. Second, post-hoc interpretation. This adds explanations to existing models after they've been trained. So you take a black box and make it explain itself. Methods like LIME, SHAP, and attention visualization. But here's a critical risk. These methods may not be faithful to actual model reasoning. An explanation can be clear but wrong. Third, inherently interpretable components. This is about building models that are interpretable by design, decision trees, sparse models, trade-off, and interpretability may reduce performance. Fourth, architecture and task-driven explainability. This designs system architectures that produce explanations as a natural part of their operation, rationale generation, and multi-step processing. Now, most real systems use a combination of these approaches. So let me expand on post-hoc methods, because these are probably what most people think of when they hear explainable AI. For local methods, LIME creates local surrogate models. SHAP uses Shapley values from game theory. Gradient-based methods show saliency maps and GradCam. Counterfactual explanations answer what would need to change. For global methods, you have aggregate feature importance, rule extraction, and surrogate models that train a simple interpretable model to mimic the complex one. The advantage of post-hoc methods is that they can be applied to almost any model, but here's the risk. These methods may not be faithful. A SHAP explanation might be plausible and understandable, but not actually reflect how the neural network made its decision. Fidelity is always a concern. Now, a crucial question. How do you know if your explanations are actually good? ISO 6254 provides a framework for evaluation. So here are the key criteria for ISO 6254. Fidelity. Does the explanation accurately reflect the model's actual reasoning? An unfaithful explanation, one that sounds good but isn't true to the model, is worse than no explanation at all. Consistency. Are similar inputs explained similarly? If 2 nearly identical cases get wildly different explanations, that undermines trust. Stability. Do explanations remain stable under small input changes? If adding a single pixel dramatically changes the explanation, something is wrong. Comprehensibility. Can the target audience actually understand the explanation? This needs to be tested with real users from your target audience. Usefulness. Does the explanation actually help users accomplish their goals? Does it improve their decision quality? Efficiency. Is the explanation delivered in acceptable time and with acceptable computational resources? ISO 6254 is refreshingly honest about the limitations. Annex C explicitly addresses these faithfulness concerns. Post-hoc methods may not actually reflect the model's reasoning. There's inherent uncertainty about whether explanations are actually true. Manipulation risks. Explanations can be gamed. A model could be designed to produce fair-looking explanations while actually being biased underneath, and this is sometimes called fair washing. Cognitive limitations. Humans have limited capacity to process complex information. More detail doesn't always mean better understanding. And the trade-offs, these are real and unavoidable. Accuracy versus interpretability, completeness versus comprehensibility. You can't actually maximize everything. So acknowledging these limitations is part of responsible implementation. So how do you actually implement ISO 6254 in your organization? Let me give you a practical roadmap. So here's a 5-step process that you can begin to follow. Step 1, stakeholder mapping. Identify all stakeholders for your AI system. Don't just think about users. Remember the AI subjects, the regulators, the auditors, and document their specific explainability needs. Step 2, requirements definition. Specify what types of explanations are needed, local or global, what forms, what depth, and critically, what are your regulatory requirements. Step 4, integration. Build explainability into your architecture from the start. Don't bolt it on later. Step 5, validation. Test your explanations against the evaluation criteria. Test fidelity, comprehensibility, and usefulness, and iterate based on feedback from actual users. So you can see this isn't a one-time process. It's actually ongoing throughout the AI system lifecycle. So here are the key questions that ISO 6254 gives you the vocabulary to answer. Who needs explanations from this AI system? What type of explanations do they need? When in the lifecycle should explainability be addressed? How should explanations be generated? How good are our explanations? What are the limitations and risks? How do we maintain explanation quality over time? And these specific questions replace the vague, is it explainable, with actionable specifics you can actually design and build to. So let me put ISO 6254 in regulatory context, because this is where it becomes really valuable. The EU AI Act, which came into force in 2024, requires that high-risk AI systems provide transparency and enable human oversight, but the regulation doesn't tell you exactly how to do that. ISO 6254 provides the technical framework. GDPR Article 22 gives individuals the right to explanation for automated decisions. ISO 6254 defines what constitutes an adequate explanation. Various sector-specific regulations, FDA guidance for medical AI, fair lending requirements in finance, all require some form of explainability. ISO 6254 provides a common implementation framework. So let me now summarize the key takeaways. First, explainability is not a binary checkbox. It's a multi-dimensional property with many facets. Second, different stakeholders require different explanations. There is no one-size-fits-all. Third, explainability must be designed into the AI system lifecycle, not just bolted on at the end. Fourth, there is a taxonomy of methods. You need to choose appropriately. Fifth, explanations themselves must be evaluated for quality, fidelity, and usefulness. Sixth, trade-offs exist and are real. Acknowledge them and document them. And finally, this is a technical discipline, not just a marketing claim. ISO 6254 gives us the rigor to make explainable AI mean something real. So here's my call to action. Stop using explainable AI as a buzzword and stop treating it as a checkbox. Stop posting about it on LinkedIn without understanding what it actually means and how businesses can actually use this. Start implementing it as a technical practice. Start with stakeholder analysis, define real requirements, choose appropriate methods, and evaluate your explanations. ISO/IEC Technical Standard 6254 is your roadmap. It's 69 pages of actual guidance that most of your competitors probably don't even know exists. So if you're serious about responsible AI development, get a copy of this standard and start using it. So here are some resources if you want to dig deeper. The standard itself, 6254, is available from the ISO store. And yes, ISO standards cost money, but this one is worth it if you're working in this space. Related standards includes ISO/IEC 22989 for AI concepts and terminology, and obviously most of you will know about ISO 42001 for AI management systems, and also ISO/IEC 23053 for neural network frameworks. For technical implementation, The Interpretable Machine Learning book by Christoph Molnar is an excellent free resource. The SHAP library and Captain for PyTorch are practical tools you can use today. And of course, stay informed on regulatory developments such as the EU AI Act, GDPR, and the NIST AI Risk Management Framework. So thanks for watching, guys. If you found this video helpful, please like and subscribe, as it really helps my small channel. And drop a comment if you have questions about 6254 or explainability in general. And remember, the next time someone on LinkedIn tells you their AI is explainable, you now know the right questions to ask. Explainable to whom? In what form? At what depth? How do they validate fidelity? And if they can't answer those questions, they haven't done the work. So until next time, thanks for tuning in, and thanks for watching AI Governance Engineering with myself, Gavin. Take care.